multi-signature wallets on Ethereum and how you can actually code one yourself. Okay, I'm explaining what multi-sig wallets are, why they're such a big deal, and if you're going to become a blockchain developer, why you need to understand this stuff and understand it, see how it works at a basic level, which is exactly what I'm going to show you how to do in this coding session today. All right. So let's just go ahead and dive in here and get a conceptual overview of what we're talking about. Let's look at what a multi-signature wallet is, why it's important, why you might want to use one in the first place, okay? So let's take, an example of how most people hold their cryptocurrency. We're going to use Ethereum as an example because that's what we're going to focus on for this particular video. So let's talk about just the ETH cryptocurrency itself, okay? So let me just get this to work here. All right, so say you're holding ETH. So most people who are just, casual holders of this cryptocurrency are going to hold it a couple different ways. One is they might just buy it on an exchange and hold it on exchange and never, withdraw it. But hey, that might be good if you're just speculating on the price and you want to sell it at some point and you're not holding very much, okay? But if you actually want to do stuff with the ETH, maybe you want to use it in DeFi, maybe you want to buy an NFT, all right? Whatever. Or maybe you just want to self-custody because you don't want it sitting on an exchange, not your keys, not your crypto. Then you might withdraw it to a wallet like MetaMask, for example, okay? So, this is an example of a MetaMask wallet where you can hold some Ethereum in it. You can connect to the main Ethereum network. But there are a couple problems with this, okay? If you hold a large amount of money in here, if someone got access to your computer, okay, and they could just, take your ETH balance and click send, then they could transfer all of your funds out of your wallet with a click of a button, because that's all it takes. It's just a single button click with one device, and, they could transfer this money out, okay? So, it's still fine for people who don't have very much money in their MetaMask account, but when you start increasing this amount of Ether, let's just say you got a lot of Ether, then if you're just operating, if you're operating solo, then you might increase the security scheme by having a hardware wallet, where basically, you have a MetaMask account, and then you add an additional authentication factor, which is a hardware device to when you go sign this transaction, somebody would need your computer, but they'd also need your hardware wallet attached to it, and, some ability to know the PIN to your hardware wallet, or maybe some sort of biometric sensor that would authorize the transfer of the Ether funds out of your wallet, okay? So that is sort of an additional level of security. Now, if you want to take things even farther, you can go to a multi-signature security scheme, okay? Now, what this means is that multiple different parties have to sign a transaction in order to authorize a transaction and send it. So what do I mean by that? Well, basically, anytime that you send cryptocurrency, if you're a MetaMask wallet like this, for example, let's say I send ETH from my account to yours, then basically what I'm doing is I'm creating a transaction on the blockchain, and I'm signing it with my private key. So in the case of just a hot wallet like this, just a MetaMask wallet that's connected to the internet, connected to the Web 3.0, connected to the blockchain, this private key is just living inside of MetaMask. All right, so either you have a seed phrase that you've imported into MetaMask, or maybe you've just, copied and pasted a private key and put it into MetaMask. Either way, MetaMask is controlling the private key, and you would sign the transaction for that. You would sign that transaction with your private key that lives inside of here. And when you go to a hardware wallet, that private key actually lives on the hardware wallet itself and never touches your computer, so that it increases its security. Now, how multi-signature gets even more robust is it takes multiple different private keys in order to authorize a transaction, okay? So here inside of MetaMask, you just have, your one private key that has to sign a transaction, and either you're doing it here, or maybe you're doing it in a hardware wallet. But with multi-signature, it takes multiple signatures, multiple different private keys to authorize a transaction and, send out funds, all right? So, when would you want to do this? Well, there's a couple different scenarios. One is, like I was saying, if you have a large amount of money, this is kind of usually the case in any scenario where you're using a multi-signature wallet. You might want to use a multi-signature wallet if you yourself control a lot of money and you want multiple different private keys to sign it, that basically reduces the failure point that someone could steal that money from you. Let's say you had millions of dollars in cryptocurrency. I don't know, like $100 million or something like that. That's a lot of money. You don't want somebody to be able to just find your hardware wallet or your private key, and if they found that one thing, then they could just take all this money from you, okay? So maybe you have a multi-signature scheme where you have multiple wallets that all have to sign to authorize transactions from a given address, all right? Actually, just to move that money out. So that's one way, whether you're an individual and you control a lot of money. Maybe you control each private key, but you also might have this in a scenario where essentially you have funds that are belong to an organization, or it's not, where maybe they don't apply to a single individual, okay? Maybe they belong to a DAO, maybe they belong to just a traditional company, and there are multiple people who are shareholders in that company, or have a vested interest in that company, or are simply employed by that company and are responsible for dispersing those funds. Well, you can implement a multi-signature scheme there where basically it takes multiple people to sign off on a transaction before funds are released. Maybe this is for payroll, maybe this is for just treasury funds that the company holds, right, that they can do with whatever they want to. That's another place where multi-sig can come into place, and it keeps one person from just running off with money. Or maybe it prevents, errors from happening where you have multiple people who are double-checking a transaction before it gets sent somewhere, okay? So this would look like a couple different things, where maybe you have a 3 of 5 multi-signature scheme where you register 5 different private keys or 5 different individuals, right? That might be able to authorize transactions from a multi-signature wallet. And, as long as 1, 2, 3 of any of the 5 people, sign off on that transaction, then you could, release those funds. Maybe you do 2 of 3 multi-sig. Maybe you do, a 5 of, or a 7 of 10, or 6 of 10, whatever it is, right? The whole idea is to have a majority of valid signers sign a transaction before it can get released, so that you don't have minority membership collude with one another in order to release funds, okay? And so that's how a multi-sig wallet works, okay? So as opposed to a traditional wallet where you just have one person that controls the private key, this is how a multi-sig wallet works, where multiple parties have to authorize transaction. So there are different multi-signature schemes on different blockchains, but how it works on Ethereum is multi-signature wallets are smart contract based, okay? So there are lots of famous examples out there. The Gnosis Safe, for the Gnosis multi-sig wallet, is a pretty popular example of a multi-signature implementation that's trusted by a lot of different people. Huge names in here: Consensus, Synthetics, DNS, Balancer, Kyber, etc., etc. All right, you can use it on the desktop, mobile, or the web. Okay. There's also the famous parity multi-signature attack that happened a long time ago. Okay, I accidentally killed it. This was a huge bug that left over 150,000 ETH permanently frozen in 2017 as the hacker, air quotes, accidentally killed it. All right. So this was a huge, huge deal when this happened. And so that's definitely one you want to remember for the history books. But let's talk about how you can create your own multi-signature wallet. Because at the end of the day, this multi-signature implementation is just a smart contract implementation. It's kind of a solved problem. You don't have to reinvent the wheel every time. But if actually seeing the coding implementation and seeing how it works will help you understand how the technology works under the hood and ultimately make you a better blockchain developer. So let's go ahead and jump into that. All right, so let's go ahead and get started. So definitely check out the code solution down in the description below. I'm viewing this on a GitHub repository, but you won't have access to this. So just make sure that you download the coding zip file. There's really just 2 important files in here: the Solidity file for the multi-signature wallet, and then the README file that gives you the instructions on how to actually do this, okay? So we're going to step through this, and the good news is there's only one file for code that you have to worry about, and we can do everything inside of our browser. We don't actually have to install anything on our computer to get started, so it'd be nice and kind of easy to see how this works. And so we've updated this for updated this for the latest version of Solidity as well, so it should work nicely. Okay, so go ahead and get the code from here. All right, and we're going to go to remix.ethereum.org. This is our browser-based IDE that let us, create Solidity smart contracts for Ethereum and deploy them directly from our browser without having to set anything up on our computer. So just go over here, find the contracts, folder here, and click on this. Create a new file. We'll call it multisig wallet. .sol, S-O-L, okay? And so I'm going to go back to the code here. I'm going to click raw. I'm actually just going to copy and paste it for now and just deploy it and set it up so we can see how the code actually works, okay? So I'm going to put this inside of here and we're going to just follow the setup steps here, and then we'll talk about how it works, okay? So let's just do that, and then we're going to go to the compile, okay? Let me pull this over. Bring this back so we can see it. All right. So what we're going to do is do the compiler version with the correct Solidity version. So it should work. Let's actually go to 0.8.3. All right. So we actually have a compatible Solidity version here. Let's click on the compile button, and everything works. All right. And then let's go to the deploy and run transactions page. Okay, if you don't see the compiler or the deploy and run transactions page, just go to the plugins here and search for these. Like you can look up compile. I've already got it. You can look up deploy, run. Yeah, I don't see them in the search results, but you should look for the deploy keyword. If you don't have it, it should come up. Anyways, sometimes if you use Remix for the first time, they don't have everything configured here. So anyways, now let's deploy it. So we can basically just use the JavaScript virtual machine. That way we don't even have to have MetaMask installed to do this. We can make this as simple as possible. So the JVM JavaScript virtual machine is just it's a test blockchain that runs in our browser built in JavaScript. So you might have seen some development blockchains that I use for my other tutorials, like Ganache, for example, either the CLI version or the GUI version, where we have an app that basically lets you run a point-and-click blockchain, or maybe a command line tool where you can spin up a test blockchain. This is kind of similar, but now it's in your browser so that you don't have to, install stuff on your computer. It makes it really nice, okay? So we can just use the JVM here, JavaScript virtual machine here, and we can, this is going to give us 10 accounts for free. We can choose any of these accounts. I'm just going to use the first one by default, okay? And we are going to deploy the contract, but I'm going to go over the code here in a second. But let's just look at some of this code first. Basically, what this code is going to do, we'll just talk about it now. What this code is going to do is actually keep track, first and foremost, of the different people who are required to sign transactions. Okay, so let's just pull this up so you can see it on my whiteboard here. So for the multisig. Again, you're gonna have like let's just say we have a 3 of 5 scheme where we have 1, 2, 3, 4, 5 people, and we're gonna say that any of these 3 people, if they sign it, then we're gonna authorize a transaction. Well, now we have to keep track of all 5 of these people so that we can understand who the 3 of 5 are in order to implement this scheme. Okay. For this example, say let's just use 3. All right, we'll use a 2 of 3 scheme. So 1, 2, 3. We'll just make it as simple as possible and say this person and this person, or any combination of 2 people. All right, we'll do 2 of 3 multisig. Okay. So we need to keep track of each of those. So let's just take the first 3 accounts in the list. All right, and we're going to keep track of them in the owners here. So basically, if you look at this constructor function, this is the function that gets called whenever the smart contract is put on the network. So this is run once and only once whenever the contract is deployed. And the constructor function takes a couple different arguments. So the addresses, this is going to be the people of the owners, and the number of confirmations or signatures required, okay? So we're basically going to say that the owners, it requires the owners, and then basically has valid data whenever you do it. All right, and then it takes these owners and it puts them, it tracks them inside the smart contract, okay, for the wallet itself. All right. So you can add the arguments to the deploy function by clicking the drop-down menu here, and we need to copy these. Let's just copy it. All right, and then we're going to put it in an array, so inside these brackets like this, and then let me actually just show you my text editor so that it works properly. Okay, so we're going to format the text like this. All right, I'm going to take these addresses. I just want you to be able to clearly see what data I'm typing in there. Copy the address number 2. All right, and then copy this address here. And then we're going to put it in here. All right, and so what we're going to do is also wrap each of these addresses in strings. Okay, so like this, and it's separated by commas, and then we're going to put it inside of an array. Okay, so we'll do that, and we'll copy it back into here, put that into the owner's argument. So it's this array of strings which contain the addresses. All right, and for the number of confirmations, we'll say at least 2. Okay, so 2 confirmations required. That's the whole idea, is that we're doing a 2 of 3 multisig. So if you have 2 owners, we need 2 confirmations. All right, and then we are going to click the transact button. Okay, and now you can see the deployed contracts here, and this is now our multi-signature contract that we can interact with. All right, so now let's actually interact with the contract and see how it works. Okay. So you can see the functions listed here on the side. This is going to be basically there's get functions and there's set functions, or said another way, there's read functions and there's write functions. So the read functions are here in blue, and the write functions are here in in orange. And so basically the read functions are the ones where we can just fetch information for the blockchain. These will be free. And then the write functions are the ones where we have to pay and actually create new transactions. We have to pay Ether to do this. And these are the multiple signing steps that we'll have to do in order to, actually move funds from one account to another with this smart contract. So the first thing that we'll do is actually get the owners. Okay, you can see here the owners, and this actually matches the accounts that are first in this list. Okay, this person was a deployer, so they changed the address here. We can see you can see information. If you want to get information about a transaction, you can actually put in the transaction index and see information about it. We're going to skip that yet, and is confirmed. We'll skip the rest of these for now, okay? So, but basically, let's just actually execute a transaction, and you're going to see how it works, okay? So the first thing that we need to do is actually send some Ether to the contract so that it can authorize, transactions from it. All right, so for now, what we're going to do is actually send some Ether to the contract so that we can transfer it around like this. Basically, we're going to try to send 10 Ether. So we're going to go up here to this gas limit and value section, okay? And we're going to put in, 10 Ether. Okay, and we're actually click this low-level interaction, click the call data, make sure this is cleared out, or else it'll give you an error here. And then we're going to just click transact, okay? And now we can see that the receive function was triggered. That's this function here. Let's just see, receive. All right, and this is actually the function that gets triggered whenever Ether is sent to the contract, and it emits this deposit event. So you can see that here with this address, to multi-sig wallet receive, and then the address that this is the contract address, is the address it came from, and you can see the value here is 10 Ether, or this many way, 10 followed by 18 decimals or 18 zeros with no data. Okay, and you can see that, if you want to see more, there was an event that was emitted, right? It was here's the logs that have that deposit event. So now the contract has a balance of 10 Ether. And what we want to do is actually show you how to get the funds out of this by actually going through the multi-signature process. So there's going to be a couple steps here. The first step is to submit a transaction. This will just tell you who we want to send the Ether funds to. So you can see the funds have left this account. Let's just take the last account in the list who is not part of our multi-signature party and copy it. Okay, and then we'll say that's who we want to submit the transaction to. All right, let me just fill this in off screen because it'll probably populate some weirdness. Okay, all right. So that's who we want to send it to. The value, let's do 10 Ether. So you do 10 followed by 18 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. And then we'll click, let's just make sure we have a multi-signature party selected. We'll just do this number 3 here. We'll click submit transaction. All right, and let's see. We'll see if it worked here. All right, and so you might find a little bit of an error when you do that. So I'm going to show you how to fix it. So let's just change this. So let's try to submit transaction all over again. Okay, so I'm going to repeat this step. I'm going to go look at the last account on the list. All right, this can be our recipient. I'm going to copy this. I'm going to put the to address in there, just like this. For value, we'll do 10 Ether. So 10, and then followed by 18 decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then, so here's the kicker. For bytes, or this data at the end, you got to put in an empty array. Okay, so let's just do this. And then, hold on a second. So we're not the owner. We got to switch back to our account. So it's kind of tricky. Go back to an account that's actually the owner. We'll just do this account because you have to be a multi-sig owner to do it. And let's click transact, and boom, there we go. So we have submitted the transaction, okay? So that's the first step, is basically you're submitting a transaction that's multi-sig to say, hey, we want to transfer funds, all right? And then next, we're going to execute the transaction, confirm transaction, all right? And so that's going to be the transaction index of 0, okay? So we'll say transaction index of 0. And then we'll do it, we've got assigned 2 of 3, so we'll transact from this account, and that's 1. And you'll notice if we try to do execute transaction and say transaction 1, try to transact, it's not going to work because we don't have 2 of 3 signers yet, all right? But if you change the account to another valid signer, which is an owner, and then you click confirm transaction, confirm transaction, they sign it, so that's the second signature. And then now, the cool thing is anybody can call this submit transaction function. All right, so we've submitted a transaction. 2 people have signed it because we've confirmed it from 2 of the 3 owners. All right, and then if you look at the execute transaction, any one of the 3 people who own the contract can execute it. So let's just do this one. All right, we'll do execute transaction index of 0, click transact. And boom, there we go. Okay. And so now you can see that the last account in the list has actually received, that 10 Ether. All right. So there you go. That's how the multisig works. So we can do a brief overview of the code here. So basically, the really important thing to watch out for, let me just bump the code up again so you can see it better. So we have this constructor function, like I said, that basically is called whenever the contract's deployed. It takes an array of the addresses that are the valid signers. That was the first 3 accounts here in the list. Then the number of confirmations, so it needs 2 of 3 confirmations. If there's 3 people, we want 2 of 3. And then basically, we have some require statements that make sure you put in valid information whenever you deploy this. And then basically for the number of owners, we keep track of owners in this owners array. All right, so owners gets pushed up into this array. And then we have a function that checks if somebody is an owner. All right, and we do this, is owner. All right, for this mapping and say it's true. And then so number of confirmations required, we set that here, this variable. Okay, so 2 of 3 is required. And then when we submit transaction, we require that only one of the parties who owns the contract, is able to do this. All right. And so we store the information about the transaction, who it's going to, what the value is for and the data is, and we put this in a transactions array, okay? And we you can see it here. So we have this transactions array, all right? And each item in that array is a struct, which is just an arbitrary, data structure that you can create that stores the information, who the transaction is going to, the value, the data, if it's executed or not, and the number of confirmations that are required, okay? So next, whenever we confirm the transactions, this is where multi-party signing comes in. So you basically, only the owner can do this. We require the transaction exists, that it's not executed, and it's not already confirmed. And basically, we take out the transaction, and then we update the confirmations. So you can see the confirmation value here, and we just increment that value. So it starts off at 0, and then whenever somebody valid signs it, we just update the number of confirmations, okay? And then, you can see here. All right, and then we confirm it from that person. And that way, somebody can't just we update their confirmations. That does not allow somebody to confirm it, just the same person to confirm it twice. You actually need 2 unique people from the party to confirm it, okay? And then finally, for execute transaction, we basically fetch the transaction. We require that it's got the correct number of confirmations, which is 2 of 3. And then if that passes that test, then we say it is executed. We update it. And then we say transaction 2, call value. And basically what this does is it just sends the ether to the recipient, all right? And then we require success. And if it's not successful, we say it's failed. And then we execute an event that says it was submitted. So that's an overview of the really important parts of this code. So that's our review of multi-sig wallets on Ethereum, why they're important. This is a really great thing for you to understand as a blockchain developer, so you can kind of see how this works under the hood and kind of get your wheels turning to see what's possible with blockchain and programmable money. So that's all I got for today. If you have any questions, feel free to reach out. Until next time, thanks for watching Blockchain Mastery University.